So, laws of reflection. Here we proceed with this topic, and this is very important, and this is not only just important for this class, this is very important topic for the class 10th also. Okay, laws of reflection are the laws through which the light travel and striking on the surface, and after that what is happening with it. Okay, so let us see the first law. There are very much obvious that I have told you here are two laws of reflection. Okay, so the first one is the angle of incidence is always equal to the angle of reflection. Okay, as I have told you that in a surface, any opaque surface you can take, so that because we are taking here smooth one, like supposingly it is mirror, and mirror is lying like this. Okay, so this is a part of mirror, and here from any source a light is coming. Okay, you can take any source, if you can place here torch also, any bulb also. Okay, but now as you can see, this light is again reflect and can be seen very sparkly at particular point. Like if something is coming from here, like here is a bulb, okay, and a person is standing here. Okay, now so person will get equal amount of the light, that is if it is directly looking at the bulb and if it is standing here and looking at the mirror, then also he will see the same amount of light that is received by his eyes. Okay, so that shows us that the light of the bulb is traveling in all direction. First thing is this, and the person who is looking here will get some amount of light energy and it is sensed by his eyes. Okay, that is okay. Now if the light is coming here and it is traveling here, if the person is not looking directly at the bulb, it is looking at the mirror side. Okay, now also he is able to see the bulb. Why? Because it is throwing the light in the all direction. Light is not just like it is sending in one direction only, it is thrown in the all direction, and this direction that is coming towards the mirror, it get reflect back, and now that reflecting light again is received by this person, and this person maybe would be able to see the bulb in the mirror. Okay, like if the person is standing here, okay, now maybe the light would not come in the direction of the person, and now he is not able to see that bulb if he is looking into the mirror, because light is not coming in the direction of him, because it is only and only reflecting in a particular direction. Okay, that's all we know. But now why only this person who is standing here would receive a light of bulb that is coming reflected by the mirror? Why not this person? Because the angle of incidence would be equal to angle of reflection. This is the law of the light through which it get reflected. Yes, this is the point of incidence, students, and from here if we draw a normal, okay, a normal is drawn here. Now you can see that this incident ray and the normal together is making an angle of I, that is angle of incidence, and this reflected ray and the normal is making the angle R, that is angle of reflection. Now these two angles would always be equal. If the angle I is 30 degree, then angle R would also be 30 degree. Okay, students, so this is the first law of reflection, and because of that only we are able to see anything. Like you are able to see your, let's suppose you are able to see the table that is in your room. Okay, Now the light from the source, let's suppose there is a bulb or a tube light in your room, and the light that is coming from there is traveling toward the table. Now table would reflect it, and it is not just reflecting it in your direction but also in all direction that is in the room. But the direction from where it is received by any other person is, we can say that the light that is reflected by the table is also going there. Okay, so all these things would get the idea of the first law of reflection. Now students, what will happen if the light is coming in this way? Like this is a normal point, and if we are perpendicularly throwing the light and it is incidenting in this manner only, like this is the incident ray. Okay, so I am writing here, that means that the angle of incidence in this case would be 0. Yes, it would be 0 because the normal and the incident ray would be same. So overlapping means they are 0 right now. Now if it is coming in this direction, then it would go in the same direction. Yes, the direction of going would be also same. So we can say that angle of reflection would be also 0. Yes, क्योंकि I और R दोनों हमेशा equal होते हैं. Fine. So angle I and angle R both are equal. So the light which is coming perpendicularly would go perpendicularly only. Okay. That is why we would not, if we want to see the light that is reflected by the mirror at this point of time, we won't be able to see that. Okay, so this phenomena works very well. You can make lots of experiment, you can do lots of things with the torch, with the help of torch and the mirror at your home also. Okay, so let's try this experiment by yourself, and let's switch to the next law. Second law of reflection says that the incident ray, reflected ray and the normal all lie in the same plane. What does that mean? So consider this diagram, students. You can see that the light of incidence, let's suppose this is the light of incidence and this is the light of reflection and this is the normal. Now you can see that this is considering in the single plane. Okay, let's suppose this is a plane surface and that plane surface is actually having all three lines. Okay, even this sheet, like whatever I am writing here over this is a single plane. If I am drawing here like this, and if I want to draw a line, another line into here, like here, if I am writing here, okay, so this is not a single plane. Single plane means that all three lines are in a x and y axis. You in mathematics have read that there are three types of axis: x-axis, y-axis and z-axis. Okay, so all the three things should be in the, whether it should be in the xy term, or if you are taking xz, so all three things would be here. If you are taking yz, then all three things would be here like this. But it would not be possible that if the x, y, z axes are here like this, and two of the rays, okay, two of the rays are here, that angle of incidence and angle of reflection is here, and one ray that is normal would be here like this, like perpendicularly, like behind this thing, okay, like here, or you can imagine like here in the xz axis. It won't be possible. Okay, that is very particular about it, that whatever the direction of the three of these ray, but all of them would be lie in a single plane, and that plane could be anything, xy axis, yz or xz. Okay, out of these three it could be anything, but should be a single plane line.